Hi, this is our project on global climate change. I'm Sarah Middleton.
I am Brad Powell.
And I'm Catherine Lisa. First, we're going to begin talking about models. Models help us with our understanding of concepts. In the process of creating the final project, we went through a process of model building. First, we began with a naive mental model. As our group started processing the information we gathered throughout the course, our model began to change form. In the next stage of the process of model building, we created a diagrammic model where we began to draw the diagrams and lay out a schematic plan to further organize our collected data, diagrams, and charts. Next, we worked on the verbal model by gathering our information and placing it in the written form of the model. Together, we worked and reworked the model until we developed the final model. By forging together all of our ideas and perceptions, we developed what we consider to be our expert model on global climate change.
Energy. The definition of energy in its simplest form is the ability to do work. Without energy, there is no application of force and work being performed. In living organisms, energy manifests itself as the work performed to carry out life-sustaining processes. And conversely, without energy, life is unable to exist.
Where does essentially all the life-giving energy on Earth originate? Our closest star, the Sun, is considered the source of this energy. We can consider the Sun to represent an ideal source of blackbody radiation with a surface temperature of approximately 6,000 Kelvin. The flux of radiation of a black body is directly proportional to the absolute temperature. The Sun radiates 99% of its electromagnetic radiation in the wavelength of 0.15 to 4.5 micrometers. This electromagnetic radiation is capable of traveling through the 93 million miles from the Sun to Earth in the vacuum of empty space.
The Sun's energy is divided into the following categories: a negligible amount in the gamma and X-ray wavelengths, 9% in the ultraviolet wavelength range, 45% in the visible light wavelength, 46% in long wavelength, which is infrared, radio, and microwaves.
As the energy in the form of electromagnetic radiation from the Sun enters the Earth's atmosphere, the following events occur. The ultraviolet wavelengths are absorbed by the ozone layer. Water vapor and CO2 absorb infrared wavelength beyond the 1.5 to 2.0 micrometers, and the wavelength of electromagnetic radiation between 0.3 to 2.3 micrometers is incident and absorbed by the Earth.
In summarizing the energy balance of the net incoming 342 watts per meter squared of radiative forcing, 30% is reflected back to space, 16% is directly absorbed by the atmosphere, 50% penetrates the atmosphere and is absorbed by the Earth's surface. The absorbed radiation is re-radiated to the environment as long-wave radiation. The behavior of solar radiation differs on land and sea. On the land, energy is absorbed close to the surface. The warming and re-radiation happens quickly. In the sea, energy penetrates much more deeply. Sea surface is warmed much more slowly, less energy is lost to space. The large heat capacity of the oceans acts as a climate flywheel to dampen the fluctuations in the global climate.
The greenhouse effect. According to Wikipedia, greenhouse effect is a process by which thermal radiation from a planetary surface is absorbed by atmospheric greenhouse gases and is re-radiated in all directions. Since part of this re-radiation is back toward the surface, energy is transferred to the surface and to the lower atmosphere. As a result, the temperature there is higher than it would be if direct heating by solar radiation were the only warming mechanism. This is a normal process that makes life possible on Earth. Earth's average temperature without the greenhouse effect would be minus 18 to minus 19 degrees Celsius. Earth's average temperature with the greenhouse effect is 14 degrees Celsius.
Greenhouse and radiation imbalance. This would all be peaches and cream if the energy balance for the climate energy was actually balanced. Essentially, energy in equals energy out. Unfortunately, Earth's energy equation is unbalanced with a net positive radiative forcing of 1.6 watts per meter squared. According to IPCC, given the total surface area of the Earth, this amounts to an impressive 800 terawatts. One way to think of the positive radiative forcing effect is to imagine a bathtub with more water flowing in than draining out. Ultimately, we can envision a disaster of the tub overflowing.
Causes of global climate change. There are natural and anthropogenic causes of global climate change. Some of the natural causes are solar variations, volcanic activity, plate tectonics, ocean current, and orbital variations. Natural variations may be large and affect global climate, such as Mount St. Helens, but these effects tend to be short-lived, and some, such as orbital variations, are predictable. Anthropogenic causes of climate change include fossil fuel burning, deforestation, ozone hole, dust, and aerosols. These have caused a buildup of greenhouse gases and associated warming observed since the beginning of the Industrial Revolution.
Global climate change is having many effects on our Earth. Glaciers are receding, ice sheets are breaking up and melting, sea levels will eventually rise because of this. Ocean water chemistry is also changing. The oceans are becoming more acidic, which is damaging to coral reefs and shellfish. There is a rise in the surface temperature of bodies of water, and extreme weather patterns can result from the changing climate.
There is evidence that the observed effects of climate change are because of anthropogenic increases in greenhouse gases such as carbon dioxide, nitrous oxide, and methane. Charles Keeling was the first scientist to take data and record the rise in carbon dioxide. His famous Keeling curve shows the increase in carbon dioxide from the 1960s. On the Cornell University Energy Studies and College of Engineering website, there is a graph that shows the historic observed temperature anomalies compared with the Keeling curve. This graph shows a correlation between the increase in carbon dioxide and the increase in global temperatures. Another piece of evidence is predictions made from mathematical models. The types of climate models used are energy balance models and global circulation models. Both models are used by climatologists to model past and forecast the future climate parameters such as average temperatures, precipitation, ocean circulation patterns, and El Niño and La Niña. Proxy methods are also used to find data on past climates and to learn how the climate has changed over time. Proxy methods include ice cores, tree rings, seafloor sediment, and fossils.
The IPCC, or Intergovernmental Panel on Climate Change, is a United Nations-endorsed scientific body that reviews current scientific, technical, and socioeconomic information relevant to understanding climate change. Because of its scientific nature, it provides a rigorous opportunity for fact-finding. The goal of the panel is to provide information for governments to use in making policy decisions regarding climate change. The IPCC's executive summary states that continued greenhouse gas emissions will cause further warming of the Earth. It will also induce many changes in the global climate system that would very likely be larger than those observed in the 20th century. We found an article from the peer-reviewed journal Global Environmental Change titled Effects of Climate Change on Global Food Production under SRES Emissions and Socioeconomic Scenarios. The authors are studying how global climate change, in particular rising carbon dioxide emissions, are raising global mean temperatures, which will affect crop yields, and therefore the risk of hunger in developing and developed countries. To study this, the authors used the HAD-CM3 global climate model under the IPCC's Special Report on Emissions Scenarios. The outcome of the study shows that the world as a whole will be able to supply enough food for the global population. However, this is due to an increase in crop yields in already developed countries, while developing countries will experience a decline in crop yields. This can lead to increasing prices for food in these countries and a higher risk of starvation or hunger in developing countries.
Mitigation. There are actions we can take to decrease the anthropogenic causes of global climate change. Some of these mitigation actions are green living, which are your personal choices, energy efficient technology, renewable energy sources, decreased carbon footprint by cap and trade, or a carbon tax, or carbon sequestration.
There are some people and organizations that believe anthropogenic climate change is non-existent. They believe that all global climate change is natural and not caused by man's activities. They believe that any attempt to mitigate carbon dioxide emissions will lead to undue economic harm. Skeptics defend their position with arguments that state global climate change models are not reliable. The climate has changed in the past and that carbon dioxide levels were higher at a time in the past than they are presently. Skeptics use these points to argue that global climate change is natural since it has occurred in the past. They say that the portrayal of recent increase in temperature on graphs that correlate to an increase in carbon dioxide are part of a natural climate fluctuation.
In closing, with all the information we've learned and discussions we've taken part in, we, the believers of climate change, still have a hard time arguing for government and private sector intervention to reduce anthropogenic contributions to global climate change. Skepticism, procrastination, and the inertia of pre-existing habits are obstacles to a serious and sustained call to action to combat present and future global climate change. We understand this flaw in present-day thinking and believe that there is correct argument and course of action based on comparing the two scenarios of action versus inaction. The argument for action and against inaction is based on which behavior produces the best results given the possible worst-case scenarios. A call to action is clearly and intelligently argued by Wondering Mind 42, that is associated website. To paraphrase Wondering Mind 42, action may be costly, and doing so may harm our economy and our standard of living, but the benefit of such a sacrifice may result in humankind preventing most of the devastation caused by climate change. However, inaction in the worst-case scenario may result in the end of civilization as we know it. This is a no-brainer. The end of civilization as we know it is unequivocally tips the choice of behaviors in favor of action. If there is an economic distress, this is a small sacrifice as opposed to possible annihilation. In closing, the biggest weapon against anthropogenic global climate change is the well-informed, and that the well-informed must take action. Our goal must be to educate the less informed by making the argument that emphasizes the absolute devastation caused by possible humankind's inaction. This should awaken the sleeping giant of the silent majority out of their stupor of complacency. Thank you for listening to our presentation. This has been Brad Powell,
Sarah Middleton.
Catherine Lesa.